Good morning, everybody. We're now going to start chapter 4. With chapter 4, our focus is going to be more on how to use calculus to interpret graphs of functions. Section 1 deals with what are called monotonic functions and the first derivative tests. Okay, first off, a monotonic function is simply this. It's a function that is either increasing or decreasing on an interval. Okay, so what does that mean? We have to look at what what does decreasing mean with respect to functions. All right, but to do that, we have a corollary. Corollary 3. Corollary 3 tells us what it means to be increasing, decreasing. Suppose the function f of x is continuous on a closed interval and differentiable on the open interval AB. But differentiable, give me here. It's continuous, there's no breaks. Every point has a limit that approaches it from both sides. Differentiable means that it has a slope, which what that means is first derivative exists at each point. Now, the reason the endpoints are not included is because you really can't take the first derivative at an endpoint. It's because it's not approached from both sides. So we look at open intervals there. So the difference are increasing functions. Increasing functions are these. If the first derivative of that function is positive at each point x on the open interval AB, remember you have to be able to take the derivative of it. So if the first derivative for any x inside the interval, if it's always positive, then it's an increasing function. Remember, slope is the first derivative. So if it has a positive slope, it's increasing. Decreasing. A decreasing function. If the first derivative at x is less than 0 at each point x in the open interval AB, then f of x is said to be decreasing. Like on the closed interval, because that's the interval we're looking at. On the closed interval. So basically, what we're looking at here is the slope. Same as algebra. If the slope is positive, it's going up. If the slope is negative, it's going down. Simple as that. Let's look at an example here. And then also using calculus, we can find out what intervals is it increasing or decreasing. Example 1. Find the critical points of our function f of x equals x cubed minus 12x minus 5. And where it is increasing and decreasing. All right, so let's look at what do they mean by critical point, or this case, look at critical values. The critical values are points in which it doesn't have a slope. Their slope is 0. Because if you have something that has a slope 0, at this point, your vertex, you have the slope equals 0, which is your first derivative. We can tell at this point, now is it a maximum or minimum? Well, if the first derivative is positive to the left and the first derivative is negative to the right of that point, then it's a maximum. Because it's going up, then it's coming down. And conversely, if it's going down, then going back up, then it's a minimum. So find the critical points. So the first thing we have to do with our function is take the first derivative of it. X squared minus 12. Now, why do we have to know this? Is because here find where the first derivative is equal to 0. Because we want to know at what points does it stop being positive and negative. So set this equal to 0. We know we're going to have 2 points here. So add 12 to both sides. Divide by 3. We have x squared equals 4. Square root both sides. X equals plus or minus 2. Those are my critical values. Now, what does that tell us? What it tells us is this. On our graph, at this point and at this point, will have vertices. So now what we have to look at here. So we know it's somewhere along this line, wherever the graph crosses at that line, those lines, we know it's going to be the vertices somewhere there. But which quadrant are they going to be in? Well, let's look at the -2. What happens if we put -3 inside the first derivative? We get 3 times -3 squared minus 12. -3 squared is +9. 3 times 9 is 27, is 15. The number is irrelevant. It's positive. So we know on this side it's going up. I'm betting between these two, since this one's going up, this between here, the slope will be negative. So let's take f of 0. So we're first going to take -3, then we're going to take 0. So we have 3 times 0 squared minus 12. So it's negative. Again, the first derivative, it's negative, so it's down. And then to the right of the critical value, I put in 3. So f prime of +3. 3 times +3 squared, 3 times 9. So it's going to be the same thing. It's going to be positive. So we'll have a max here. We'll have a min here. And to know exactly what's going on, we have to plot some points. So this leads us to what's called the first derivative test. Leads us to the first derivative test for local extrema. Or it's going to tell us about where the vertices are. And then we're going to learn something else to see what another thing about the shape of these curves. Remember, at vertices, all vertices have slope equals 0 because it's either the top or the bottom. So it's a horizontal slope, which means the first derivative at those points are 0. And here it is. Here's the test. Once we find the first derivative, we'll look at those things. If the derivative changes from positive to negative as x is going to infinity, some point C inside the interval, open interval. So if it changes from positive to negative, then the function has a maximum at f of c. If the values of the derivative changes from negative to positive as we go to the right, at some value c within the open interval AB, then f of x, remember, if it's got negative, it's going down, then it's going back up, then the function has a minimum at f of c. And lastly, if these are changing positive and negative, if it doesn't change signs, at C. Now, what do you think that means? Then the function does not have an extreme. That's at that point. Or it's horizontal at both sides. It's here's C, and there's that. There's C. Example 2. F of x equals x to the power 1/3 x minus 4. Find the critical points. That's 1. And find the intervals where it's increasing and decreasing. So the first thing we got to do we're going to take a derivative. So distribute. This is the same as 3/3 because 1. So x 1/3 times x 3/3. We add the exponents minus 4 to the power 1/3, which is x to the 4/3 minus 4x to the 1/3. So the derivative of this first one is 4/3 x, subtract 1 minus 1. So it's 3/3, makes it 1/3, minus 1/3 times 4, and subtract 3/3 makes it x to the negative 2/3. Which it shows us this is 4/3, 4/3. Would be x to the power 1/3 minus 1/x to the 2/3. Let me write that down on the next page so we can see what we have. So our original function was x to the power 1/3, x minus 4, our first derivative, 4/3, x to the 1/3, minus 1/x to the 2/3. Let's combine these two. So this one's over 1, so it needs x to the power 2/3 over x to the power 2/3. Minus 1/x to the 2/3. X 2/3, x 1/3, so it's 2/3 plus 1/3 over x 2/3 minus 1/x 2/3. We have 2/3 plus 1/3 is 3/3, which is just 1. So it's x to the first over x 2/3 minus 1x 2/3. So it's x minus 1/x 2/3. So the only way a fraction can equal 0 is if the top is 0. So that's a 0. That's an x-intercept. And x cannot equal 0. It's an asymptote. It's not a closed interval, so there's no endpoints. Okay, so now we got to find out where we can have critical points. Let's look at both of these conditions, because if we look at our critical points. The first one we have is x equals, we cannot equal 0, and we cannot, and equals 1. So it cannot be 0 because it's an asymptote, and 1. So what interval do we have here? We have from negative infinity to 0, from 0 to 1, and then from 1 to infinity. Because on our graph, we can't use 0, and 1, we have an actual, we said that equals 0, so that's our 0. It's our vertex will be at that point. So let's look at, these are the intervals. So let's pick a value inside here, say -1. Between 1, so let's make it 1/2. And between this one is 2. So we'll pick a value that's inside those intervals. And now we're only going to check to see if it's increasing or decreasing. Remember, we want to know what the slope is doing. So the formula we're using is this one right here. This is the first derivative. So if we put -1 inside there, we got 4/3 -1 minus 1 over negative 1 2/3. That equals 4/3. -1 minus 1 is -2. Since it's squared, it's 2/3. So -1 squared is +1. So it's 1. -8/3. So the answer is negative. So it's going down. At 1/2, we have 4/3, 1/2 to the power 2/3, 1/2 minus 1. The bottom's going to be positive because if you square it, you get 1/4, and that's going to be positive. On the top, we have 1/2 minus 1. It's going to be -1/2 over the positive number. So the answer is going to be negative. Let's see it too. 4/3, 2 minus 1, 2 to the power 2/3. That's positive. This one's positive. 2 minus 1, so it's positive, so it's increasing. So what we see here, so we're asked to find, what was the question? Find the intervals, increasing and decreasing, check. Find the function's local and absolute extrema points. Well, we don't have any endpoints, so we have no absolutes, because it keeps on going forever and ever. And that doesn't tell us anything, it's negative. So we have down then up, so we have a minimum here at 1. Well, since all of these are decreasing, and that's decreasing even further, so this is also an absolute minimum, because it's just, it keeps going down, and then it goes back up. So it's absolute minimum there. Let's go to example 3. The CPs of f of x equals x squared minus 3 e to the x. We'll find the intervals where it's increasing and decreasing. Find the functions local and absolute extreme. All right, so again, the first thing we have to do is find our derivative. Now it's going to be pretty tricky because we have our function x squared minus 3 times ex. This is f and this is g. F, g, f prime, g prime. So it's x squared minus 3 e to the x. So 2x e to the x. So the first derivative, 2x e to the x plus e to the x, x squared minus 3. They both have e to the x. So I'm going to take that out. We have 2x plus, drop the parentheses, x squared minus 3. Rewrite that in decreasing order. X squared plus 2x minus 3. This one can never equal 0. So all I have to do is worry about these. If we factor these out, second sign is a minus, so they're opposite signs. One's plus, one's minus, and the bigger one gets the first sign. So the bigger number is that. What times what is 3? That when you subtract them, you get 2. 3 times 1, 3 minus 1. And the bigger number gets the plus, so it's 3 and 1. Set those equal to 0. So x equals negative 3 and x equals 1. Those are my critical values, but not really points just yet. So let's look at the intervals that we're looking at. We're going from negative infinity to negative 3, negative 3 to 1, and then from 1 to positive infinity. Test points. So take some values inside there. So let's say negative 4. Between negative 3 and 1 is 0. Between 1 and infinity is 2. Plug them in the first derivative. So for the first derivative, we'll use this function, e to the x, x plus 3, x minus 1. E to the negative 4. Negative 4 plus 3. Negative 4 minus 1. Negative 4 plus 3 is negative 1 times negative 5. The answer is positive 5 over e to the 4th. It's still greater than 0. So it's positive, it's increasing. At 0, we got e to the 0. 0 plus 3 times 0 minus 1. So we have e to the 0 is 1. So we have 3 times negative 1 is negative 3. It's negative, so it's decreasing. So here we have a max. And at 2, you have e squared, 2 plus 3, 2 minus 1. So e squared, 2 plus 3 is 5, 2 minus 1 is 1, so it's 5e squared. It's positive, so it's increasing. So here we have a min. And the graph, this one looks pretty weird. We have negative 1, negative 2, 1, 2, 3. So our critical points were at negative 3 and 1. Also it's at negative 3. It goes back up just before 2. It looks like that. All right, let me see if there are any more examples. Nope. That's it for that section. Find the first derivative, set it equals 0. Those are your points where you have a maximum or minimum. Then pick some test values, which are in the intervals. Plug them in there. Only thing you're worried about are the signs. Don't worry about the number. If it's positive, it's going up. If it's negative, it's going down. And that's all it's asking you to do. This will help us graph these things. All right, yes, we'll have time to do the next section. Section 4.